In this video, we're going to discuss the concept of internal resistance. Now, what you are looking at over here is a typical battery. And previously, we always assumed that the battery simply produced EMF, but now we need to understand that all batteries have an inherent internal resistance, which will denote with a small r. So, what does this internal resistance do? Well, we treat it just like any other resistance in series with the battery, but we should think of it as a little component in the battery that sucks up a little bit of the potential difference that your battery is supposed to supply. And so what I'm trying to say is that if, let's say, this were a 9-volt battery, that would typically assume that the EMF is 9 volts. But does that mean you can actually supply 9 volts to the rest of your circuit, which is the external resistance R? The answer is no. And the reason is simple. It's because if you have a current now that flows through this thing, I, you know that there is going to be some potential difference or some potential drop over here, IR. And so you see, E will be equal to IR plus IR. And what we, of course, are supplying to the circuit is this one only. And so we call this the terminal potential difference, which is, you can think of it as the effective potential difference that this circuit can supply. And so another way of thinking of this, okay, we can say the terminal potential difference, which we will call V. V is simply the EMF of the cell minus the potential loss across the internal resistance small r. That's right. So this will be the value that you obtain if you connect a voltmeter across your battery. Or for that matter, if you connect a voltmeter across your external circuit. So let's just add one more thing over there. There you go. And that's the concept of internal resistance.